Okay, hello. I hope that you're doing well. So, okay, as you're seeing, I have switched the order of science and social studies for today. And the reason I did that is because I thought that it actually would be better for you just to do science because this is going to be kind of quick. It won't take you very long to do. And then I thought for social studies, it's better to do this before so that you could actually like think about it a little bit more. Because I feel like if we had the social studies lesson, it might be more tempting to say like, okay, I'm going to think about it for a little bit and then I'm done school for the day. So hopefully you've used your time up until now, up until science, to work on your social studies in advance of your group project or your group meeting again tomorrow. So today, okay, couple of things. First of all, let's just see here. Okay, so in science, I wanted you to do this from yesterday, but you know what? I forgot to put it on our agenda, even though I have it here. So 9 of you have done that. That is amazing. It's even early now, so I'm not even really going to get points. So you guys can just please work on this. Now, as a reminder, this is what we were supposed to do from yesterday, okay? So we learned about oxidization, which is basically the process of combining a substance. So a substance is going to be a different substance depending upon which of these 4 it is to produce some type of reaction. And your job was to look up what each of these are. So like what's resting and then where do you see this happening? Like you should be able to give a couple of examples. Combustion, same thing. What is it? This is just simply looking it up and then where would you see it? So couple of at least one example. And then ripening and then photosynthesis. Okay, you should be able to say at least like 2 things down here and like where you would see it happening. Could be a picture, could be words, could be a situation, kind of like whatever you want to say. Then the next part was the application question, which is how could the process of oxidization be accelerated or slowed down? So, okay, this is what I had said. So for knowledge, this is how I'm going to mark it. Okay, that's kind of easy, like full accuracy of all terms and at least 2 strong examples of each. CA, very good accuracy of nearly all terms and strong examples for each. RA, K, and so on. You can read that. Application is where you would say acceleration and slowing down of oxidization, shown with 2 different examples of each. And then CA would be done both acceleration and slowing down again, and then you have 1 example. On RA, you've either done acceleration or slowing down with an example, and then D is like, it's just not really clear or accurate. So that basically means that if you were showing how it could be accelerated or slowed down, for an E, you would do both, accelerated and slowed down, and then you would have for 2, like you would say, okay, I'm going to do how we could accelerate resting, how we could accelerate combustion, how we could slow down ripening, how we could slow down photosynthesis, or whatever kind of like example you think actually probably makes most sense depending upon the desired outcome, either acceleration of the process or slowing down of the process, okay? So if you could please do that, this is just going to count for like a homework mark. So hopefully it's kind of like an easy thing to do. And I would love for that to be submitted like today. So you could even just like pause right now while this is kind of in your mind and then start the video again after watching this. Okay, so yeah, that's just like homework thing. I don't want to be chasing people up for this at the end. So it's better to just like do it now. As you're seeing, I'm chasing people up for stuff from evidence and investigations. If you haven't heard from me, like Malik, Ali, who else is super good? Metha, Ada, Hashem, super close. Soyun, you're great. Daisy, excellent. Mohammed, great. Rami, fantastic. Rajavi, Fasi, Alex, Zaha, Christelle, and Rita. I have everything from you guys. Other people, I didn't say your name, then check your Edmodo messages and you know what I'm going to be talking about. Okay, so today we're going on to our second property of air, which is air takes up space. So this could be like another quadrant of your book or of your notes. And again, I'm not saying that you have to take notes. But when we do our show you know at the end, it's going to be easier because you get to use your notes if you have them. Okay, so what is air? All right, so just a couple of little things to go into like understanding a little bit more of how air takes up space. So, okay, Air is what makes up our atmosphere. Okay, so in our atmosphere on Earth, we have air. There is not air outside of our atmosphere, right? Or on other planets. They might have some type of gases, but they don't have like our air. We would not be able to breathe it if we went there. So air is made up of molecules. Another kind of property of air is made up of molecules that are always moving, even though we don't see them. And sometimes it might feel kind of like stale outside or like indoors, you might not be able to see the particles moving. Yeah, they are still moving a little tiny bit. Sometimes, of course, if it's like super windy, then yeah, they'd be moving like way faster, like crazy. You guys should know this a bit from grade 5, like molecules of like solid, liquids, and gases. Okay, so air, obviously gas. Okay, and then these molecules have mass and they take up space. So that means that they have a weight to them. And we're gonna be doing an experiment on that in a little bit. But today we're gonna be mainly focusing on how they take up space. Okay, so the space that the air takes up is called the volume. So you've heard of this before, right, in our measurement unit of volume, and we know that's like the shape of inside a 3D object. And yeah, the space that the air takes up is called the volume. So what volume of air is there rushing through rushing through the forest? What volume of air has to be pumped through the AC before it needs to be cleaned? What volume of air is, maybe like cold or like maybe like exhaust air, something that's kind of like a pollutant coming into your car possibly. So that's like the space, that's the measurement that would be used. It would be volume. So like meters cubed type deal, right? Volume we have in cubes. Okay, alrighty, so here we go. Can you think of some everyday examples that shows this property, how air takes up space? So if we were in class right now, I would have you start thinking about, okay, well, like, how do we know that air takes up space? Like, what are some examples that you can think of for air taking up space? So I've given you one example right here, which is like, okay, in your lungs. Like, even we're doing our breathing things, right? Like, you know that when you take a big breath in, you fill your lungs with air. Even if you take a breath in, like, to your stomach, you feel it, right? You can tell that it's taking up more space compared to it just like being like pressed out of your lungs. So what else? How else do you know? What other real life examples can you think of? So think about it right now. Give yourself kind of like a couple minutes to think about it. Okay, and you can jot down some examples. How do you know that air takes up space? What are some examples that you could think of that show that? Try to think of at least 2 minimum. Shouldn't be too bad. How do you know that air takes up space? You can also think of like the opposite. Like, what if we had a lack of air in a space? What would that look like? That might like jolt your energy or your ideas a little bit further perhaps. Okay, so here are some examples. Okay, so there's evidence everywhere in our world that air takes up space. So some examples could be, okay, so basketballs, right? Any type of like sport balls that are like blowing up, right, would be an example of that. Hot air balloons, when they're deflated, they wouldn't be like working at all. Tires, I wonder if anyone said tires. That would be a really common one for like, of course, if they're flat, then it's not really gonna work very well. You know, it has to take up quite a bit of space. Balloons, okay, yeah, okay, so if you have a deflated balloon, obviously it looks totally different than when you put the air inside of it. Air takes up space could also perhaps be even like, let me just think. Okay, so it's this shape, so it is the space that the air takes up that gives these objects their shape. So even like another example that I'm just thinking of right now is even like, I have this water bottle, right? Like if you guys do like the crushing water bottle thing where you like squeeze it, then would it be possible if you had the cap on? Would it be possible to squish this water bottle? Would it just come back to its original size, right? But if we were to take off the lid, then what would happen? Okay, so I didn't really use any different strength. Oh, now I'm gonna mess up my water bottle. Okay, whatever. Anyway, that's just an example. So I'd be curious to see what else you could think about for how you know that air takes up space. Okie dokie. All right, so here we go. Okay, this is just basically the same thing. So you have the idea of how much space the air is occupying by the size of the object. So depending upon the size of the object, then usually that gives us an idea of the volume of air that's inside of it, usually, but not always. Because an example would be tires. Because if you have some air in it, it might have the same amount of shape, but how much air is actually in that? Like, there's this thing that's called PSI, which is like the pressure of we're going to talk about air pressure a little bit later on Thursday, but basically the shape of a tire could be the same because it has a little bit of air in it, but then there's also a way to press more molecules into a space, which would give the same size, but it would just change the way the molecules look inside. So anyway, it gives us an idea of how much the volume or the shape of an object or the size of an object gives us an idea of how much air is actually in there. Okie dokie. So you don't have to write this down. This is just like kind of like showing this again. When you blow into a balloon, the air entering the balloon causes it to inflate or become larger. Of course, the air that you're putting into the balloon requires space, which causes the balloon to expand and change shape. Note. Okay, hopefully you guys get that. Pretty easy. Yeah, clearly demonstrates that. Done. Ta-da! Air takes up space. Pretty simple concept, but still an important concept. Nonetheless, I have the hiccups for air. Okay, now, what we're going to do is a couple of experiments today, or like activities. So we're going to do one that's called Paper Diver. And if we were in class, we'd be doing this together. I'd have all these like buckets set up, blah, 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 but we're not. So you guys are going to have to be creative with how you can do this at home. And then I have an extension activity for you to do as well. Okay, so first of all, for this lab or this activity, you need a couple of very simple home items, One is a glass, I suggest that you use a clear glass, not one that like be able to see through it, even if it has little ripples or whatever inside. So glass. You need a piece of paper. So either just like a single, it'll work with a single loosely piece of paper, or you could use a Kleenex, or like a little bit of tissue or whatever. So just one piece. And then you need a bucket, or you could go to your sink, or you could go to your bathtub. I'm using an ice cream bucket. Mr. Scott will appreciate this. Scottish dairy. It's from Scotland. I don't know where exactly it's made, but yeah, somewhere in Scotland. Anyway, and it's nice. Of course, I love ice cream. You guys know that. This is honeycomb. I never knew about honeycomb ice cream until I met Noel. And I don't think it's kind of good. It's like nougat kind of stuff inside. Anyway, so yeah, a bucket and water. You need to have some water for this as well. So I'm just going to explain what we do, and then I would love for you guys to try this. And I'm not going to do it because I want you to figure out what happens, and we're going to talk about this tomorrow. Okay, so this is what we do. This is the method, So first of all, you have to crumble up a piece of paper and then stuff it into the bottom of a glass, Next, you have to fill up your sink or a large bowl of water. Then submerge the glass into the bowl of water upside down. Then you have to make a prediction. So I'm just going to show this again here. So step one is, I'll just sort of show this so you can see there we go. So you have your crumpled up piece of paper. I'm going to use a Kleenex, crumple it up, and then you just put it inside of the glass, and then stuff it. It says stuff into the bottom of the glass. So you're going to stuff it into the bottom of the glass. A little bit sticking up, that's fine. And it should stay. So you have to kind of test it a little bit. So it's not like gonna, oh, sorry. I was too high from the camera. Yeah, like this will be fine. Yeah, this will be fine. But if it falls out, maybe I should use an actual piece of paper for this. Maybe I should use a piece of paper. Okay, do I have one that I could use? Yeah, okay, try this. Okay, so piece of paper, maybe I should use this instead. Oh yeah, this might be better. More solid. Okay, there. Okay, so my piece of paper is crumpled up, kind of like a blizzard when you tip it upside down. You don't want it to fall out, right? Okay, ta-da. That was my visual poem from our work with Miss Cassie. Okay, then what you need to do is you have to fill up your bucket with some water. Okay. I could have maybe put more, whatever. Okay, then what you need to do is submerge. Okay, so that means to like go like this. You're gonna bring it upside down. Okay, so it says, last step is submerge the glass into the bowl of water upside down. So you're gonna go like this. Okay, but before you do that, what you need to do is make your prediction. What do you think will happen to the paper and why? Okay, what do you think is gonna happen to the paper? Maybe make a paper that you don't really care about. Yeah, you're kind of okay if something happens to it. So what do you think is going to happen? And you might want to go to a space like, I'm not going to do this over top of my computer. That would be very bad for it. So you just remember, it's so simple. Remember these steps and then try it in a space away from technology, okay? And then, yeah, okay, so make a prediction first. What do you think is going to happen? And then observations, see what does happen. If we were in class, I would have given you a whole like lab write-up thing for this. So it would be cool if you write this down in your lab book or on your piece of paper, and do put like paper diver on there. And then, okay, then your analysis. I want you to explain why whatever happened, okay? We're gonna talk about this tomorrow in our Zoom. So you guys can kind of like sit tight on like the actual analysis. I'm gonna be curious to see what you guys have to say tomorrow. Okay, righto. So that's that. Okay, then we'll also talk about this. So you guys think about this before we get to our Zoom tomorrow. Where else in our world can this same principle be seen? So where else might this same idea, occur in the world? Okay, alrighty. Now, the next one, like I said, is another lab, and it is called Huff N Puff. Okay, we'd be doing this as well. I'd be just doing the same thing, so you guys can try this at home. Okay, so basically for this, the problem is, does air take up space? Okay, so what you need to do is, okay, so you're gonna get, I'm just gonna show you again actually here. Okay, so it's kind of cool, this one. Okay, now, I actually don't have I don't think I have a balloon left. No, I just have like the worst amount of supplies here in Qatar. Like, let's be honest. I have like 5 shirts and like I barely even have pencil crayons with me. I don't have a ruler. So, okay, anyway, I don't have a balloon. But I actually have to get some because we have another lab. So let's see if I can find some. Anyway, okay. So that's why it's optional. If you're like me, you don't have the supplies for it, that's fine. But what you're supposed to do is get a bottle that's like this, okay? Plastic bottle. Or glass, whatever. It should have like kind of like a narrow top though, and then like a bigger like mouth. Okay, then what you do is this. You have a deflated balloon and a plastic pop bottle, okay, yeah, with a narrow neck, right? So then what you're gonna do is you're gonna stuff the balloon inside of the bottle, okay? And then you're gonna sort of like seal it up like this, okay? So it's like sitting over top. It takes a little bit of like, kind of like wiggling to like get it in there and like peel it over. It's pretty easy though, really. It's fun. And then what you're going to do is you're going to try to blow up the balloon and see what happens. Like, see if it can like fill the same shape. So make a prediction first, okay? Like, what's going to happen when you try to blow up the balloon inside of this bottle? Like, what's going to happen? And then just do some observations, and then we would do the same thing, do an analysis. We're going to talk about this tomorrow, like, well, what's happening here? Okay. Yeah, that's it. That's it for today for science. So I hope that this, just a couple of things, I guess, to write down, and then mainly just like have fun trying the submerged, the paper diver. Okay. And then if you can do the Huff N Puff, try those 2 labs. Okay. All right, good. And yeah, that's it for today, I guess. So we'll actually finish this and we'll see you tomorrow. Good job.